Before we start our presentation, let me introduce what is mechanical properties. Mechanical properties are the physical characteristics that a material shows when forces are applied to it. For example, strain, elasticity, stiffness, toughness, fatigue, resilience, brittleness, and ductility. The material that we are going to discuss is bread. Bread is made from flour, water, grains, legumes, and usually combined with yeast or leavening agent. Then, it is being kneaded, shaped into loaf, and baked. There are many types of bread in the world. For example, French baguette with highly aerated crumb, crispy crust, and chewy interior. Sandwich bread with fine crumb cell structure. Flatbread with dense crumb. Next, steam bun with soft and moist skin. Multigrain bread with dense and chewy texture. And the last, rye bread with hard and chewy crust. Now, let us discuss on the factors that affect the mechanical properties of bread. First, the properties of dough. When the dough is being kneaded, gluten is formed and the dough becomes elastic and stretchy. This will cause the bread to become tough and chewy. Second, the presence of artificial additive. Properties like softness, elasticity, and resilience will be affected. For example, diacetyl tartaric acid and distilled monoglycerides. Third, styling. The bread will become harsh, dry, and crumbly due to the loss of moisture. Thus, the hardness and toughness will increase. Last, the recipes and process parameters. The quantity of raw materials and the condition of fermentation process will affect the properties of bread.
Next, let's look on the mechanical properties of bread. Compressibility is the compression ability in bread to a smaller volume. Elasticity is the ability of the formed material body to return to its original shape and size in bread dough. Gumminess is a property of having stickiness and cohesive texture of chewability in bread. Masticability is a well-known parameter in bread quality. And lastly, cohesiveness is the ability of molecule gluten to stick together in a bread. Let's move on to measurement method to determine the mechanical properties.
Before we conduct the measurement methods to determine the mechanical properties, firstly, we need to do the bread production. Raw materials of the bread were expressed by a commercial soft flour, two types of toasted durum wheat flour, tap water, saccharose or sugar, salt, and dry yeast. Did you know that there are two types of toasted durum wheat flour known as TWD1 and TWD2? TWD1 is obtained by the grinding of durum wheat grains previously submitted to toasting, which means that grains were arranged on tin pans placed on a wood fire at 250 Celsius for 35 to 45 seconds, and after that, it will undergo cleaning and dampening. For TWD2, it is obtained by the grinding of durum wheat grains of ears escaped to the harvest and roasted as a consequence of the stubble's burning. The stubble burning was a more severe heat treatment than the toasting on tin pans since it involved a direct contact of grains with fire. So, this is the ingredients for the bread loaves. For the baking procedure, the procedure was performed by using a bread making machine. First step. For the first kneading, knead for 5 minutes and take a break for 5 minutes. For the second kneading, knead for 20 minutes. Second step is for the first leavening, leave the dough for 39 minutes and follow by fast stirring for 10 seconds. For the second leavening, leave the dough for 30 minutes and fast stir for 10 seconds. For further leavening, leave the dough for 49 minutes. Last step, cook or bake for 55 minutes. Analysis of the meal. Measurements that can be analyzed are listed down here: water activity, ash content, total dietary fiber, gluten content, and colorimetric measurements. Statistical analysis. Analyses were repeated at least 3 times, 5 and 10 times in the case of volume and colorimetric analysis respectively for each sample. Means and standard deviations were determined considering that it was a nested design. Correlation coefficients, R, were calculated according to linear of nonlinear fits, and their levels significance were checked.
The next one is analysis of bread samples. According to AACC method, moisture and water activity were measured on bread samples. Next, the bread height was measured using a caliper, and the low volume was determined by the rapeseed displacement method. Some of the steps are: firstly, breads were sliced with 25 mm thickness with an industrial slicing machine. Then, from each bread, the end slices were discarded in order to avoid crust influence, and the 2 middle slices were selected. Next, discs of crumb with 3 cm diameter were cut and analyzed under certain following conditions such as crosshead speed, header, diameter of stainless steel probe, penetration depth, and sample thickness. There are some results that may be obtained from the analysis, such as the differences in water activity detected on crust and crumb of the obtained loaves may not correlated with specific formulations, probably due to the leveling effect of the bread making process. The existence of linear correlations among colorimetric indices and percentage of soft flour replacement could be checked by showing that brightness and yellow index of crust and crumb inversely correlated to the percentage of toasted flour. The change of low volume acts as a function of the amount of toasted durum wheat flours, TDW1 or TDW2. Independently on the type of toasted flour, the low volume decreased according to linear model as the percentage of soft flour replacement increased. The mechanical characteristics of crumb from loaves produced with increasing amount of toasted durum wheat flour.
For the result on meals, some physical and chemical characteristic of the flour used in bread making has detected some significant differences as the consequences of the baking process and 2 types of toasted durum wheat. Reduction of water content and changing of gluten content were determined due to heat treatment. This is because the secondary and tertiary structure of the protein preventing hydration and reducing amount of gluten formed. Colorimetric indices were detected as well as ash content and total dietary fiber contents.
The mechanical properties were the result from the tests that have been done. We have known that compressibility, maskability, gumminess, and cohesiveness, where TDW2 has higher than TDW1, but the elasticity in TDW1 is higher than the elasticity than TDW2.
There is also a method called farinograph method. It is a tool to assess baking qualities and performance of wheat flour doughs such as bread. It is used to estimate the water absorption of flours, the relative mixing time, the stability to overmixing, and properties of the dough during mixing. The farinograph test is described by ISO 5530 that measures and records the resistance to deformation of a dough against the mixing action over time at a specific speed and temperature. The parameters determined are consistency, water absorption capacity of flour, dough development time, and stability. In this case, water absorption and stability are being measured. The units used are farinograph or Brabender units, which is FU or BU. The diagram shown is representing the parts of the curve, which are arrival time, peak time, departure time, stability, as well as mixing tolerance index. From the table, the A quality group has minimum of 60% water absorption, while the B quality group has minimum of 55% water absorption. The limit value of stability is 10 minutes, at least for the A quality group. The limit for B1 baking value is minimum 6 minutes, and B2 quality group has minimum 4 minutes. Some of the results obtained are the inclusion of water absorption capacity values did not result any change between the B1 and B2 quality categories, while the samples of C1 category could have been classified into higher group. According to their water absorption capacity, the samples in the last category could have been ranked in 2 levels higher. Last but not least, after the revaluation, there are 11 samples of A2, 16 samples of B1, 15 samples of B2 and 16 samples of C1 baking value. One sample went from A2 quality group to B1 quality group. From the A2 quality group, the stability of one sample is lower than the limit value for this group. Thus, it was classified to the B1 quality group. The stability time of the sample is 9 minutes, thus it does not reach the A1 category's minimum value, which is 10 minutes.
There are other analyses that can be done on a bread testing is a sensory analysis, which is crustiness, crumbness, odor, and taste.
Equipment needed to conduct the measurement. The first one, Volscan Profiler, a benchtop laser-based scanner that measures the volume of bread and bakery products with maximum dimension of 600 mm long and 380 mm diameter with a typical test time of less than 60 seconds. The Volscan Profiler has the ability to automatically measure and calculate an additional 19 related parameters such as height, width, length, and weight. It also enables the rapid 3-dimensional digitization of products which can be archived and then treated mathematically to yield detailed dimensional information for immediate user or future retrieval. This instrument rapidly provides the accurate data essential in the fields of both quality control and product development. The second one, Rheometer, a laboratory device used to measure the way in which a liquid, suspension, or slurry flows in response to applied forces. It is frequently used for measuring the rheological properties of dough and gluten. The parallel plate configuration has the material loaded in between, and while one plate is rotating in a sinusoidal motion, the other plate is stationary. Surplus materials between parallel plates are trimmed and coated with suitable fluid like silicone oil to prevent it from drying. The common rheological parameters obtained using the dynamic oscillatory, creep recovery, and stress relaxation often related to the behavior of dough and gluten at molecular level. The third one, Texture Analyzer, a texture measurement system that moves in either an up or down direction to compress or stretch a sample. The traveling arm is fitted with a load cell and records the force response of the sample to the deformation that imposed on it. Texture Analyzer can perform compression, extension, cutting, extruding, bending, and shearing tests and measure properties such as fracturability, chewiness, stickiness, consistency, bite force, springiness, and etc.
That's all